Hello there, dear students, and we are back again to explain a new chapter and new section in grade 10 English System Physics curriculum. So we reached chapter 5. Now we are going to study chapter 5 and section 1, which is about characteristic of light. Or in general, we are going to study what is wave and electromagnetic wave and the property of the light. First of all, in here that we have some definition. First, we have to know what's the meaning of wave. Wave is the motion that carries energy through medium, or this motion are passing through medium or empty space. For example, sound wave to pass through any of the place it needs medium. For example, now I'm speaking, right? In this room, the medium is air, so my sound is traveling through this air. That's why you can hear my voice, because sound, any of the person when they are talking, it pass through any of the medium or the media which is called air. Or light wave, water wave. So these all are a type of the wave. Sound, it's wave, light wave, water wave. So we said what wave is the motion that carry energy. Look at this picture. This is in general the form or shape. This is the shape or form of wave. Look at here. This is the waveform. This waveform is carried what? Carry energy. This waveform carries energy, and the waveform, it keeps moving. For example, this is the starting point. This is the origin. This waveform start in here to keeps moving. It keeps moving, and when the wave still keep moving, and it carries energy. When these waves are moving, it carries some of the energy. So this is called waveform. So in general, this is the waveform that it keeps moving in that direction, and it carries some energy, and they have velocity, even motion. So we have types of wave, as I explained in here. We have some types of wave. For example, the first one, which is called electromagnetic wave. Electromagnetic wave do not require any medium to travel. For example, light wave, even though there is no problem if we have this place they have a medium or there is no medium, it's not a big deal, and it's not even problem. Still the light wave can pass through it. But mechanical wave, no. Mechanical wave, it needs medium. For example, sound. If there's no medium to travel my sounds, you cannot even hear my voice. And sound wave, it needs some medium to pass through it. But electromagnetic wave do not require any medium. So this is in general two types of wave. Electromagnetic wave, the definition: a wave that consists oscillation, electric and magnetic field. Important, these two words: oscillation and magnetic field, which radiate outward from the source of the speed of light. For example, look at here. For example, let me take this example. This is the sun, and the suns, the suns are giving, they give us some light. A lot of lights came out from the sun. From this is a source. Because why this is source? Because according to this, because these suns, they are giving a lot of lights came out. It can make the earth, the grounds, to be brighter and shiny. So this is the sun. This is the source. This is the source that they are giving light. So when a lot of light radiate outward, not inward, radiate outward from the sun. This is called so the type of the light that came out from the sun, this type is electromagnetic wave. Electromagnetic wave. An electromagnetic wave, it consists what? First, oscillation and it was magnetic field, because by the name you can know electromagnetic, oscillation, and magnetic oscillation and magnetic. So electromagnetic wave, a wave that consists what? Oscillation and magnetic field, which radiate outward from the source. These light are radiate outward. This is outward. It came out from this source. All the light came out from the source. And there's another point. When this light came out from the source, this light, the velocity is very, very fast and quickly, and they are moving with the velocity of the light. The speed of the light. Speed of light, which is equal to 3 times 10 power 8 meter per second. This is the speed of the light. So all of this light, even when it came out from this source, all of them, they are moving with this velocity, 3 times 10 power 8 meter per second. So now we understood in general what was wave and the type of the wave and what is electromagnetic wave. We have a general rule about the frequency in here, which is equal to 1 over t. Frequency 1 over t. T, it means the period, the time. So let me make it in here to understand. Let me draw a picture in here. We said first, for example, let me draw a waveform. For example, this is the origin, the starting point of the wave. The wave, it starts in here to keep moving in that direction. For example, we said this wave, it keeps moving and they have motion. And this motion or this moving of the wave, it carries some energy. The direction of moving in that direction. Then it keeps going to the up, then down. And it carries some energy. Now we are going to study some of the property according to this shape, on this wave. The first property that in here we have, which is called wavelength. First one, wavelength. What is wavelength? And the symbol of wavelength in physics is called lambda. This is called wavelength. Wavelength is the distance between these two peaks, or the distance between these two peaks from the up and these two peaks from the down. For example, the distance between these two peaks from the up, this is called wavelength lambda. So the distance between these 2 points in the up, this is called wavelength. The second property that we have, which is called period. Period t, measured by t. We can say time, but time with the symbol of time t small, but period t capital. Be careful. So now we understood wavelength, the distance between these 2 points from the up and these 2 points from the down. But what about period? Period is the time that need to complete one vibration. But before that, let me tell you what's the meaning of vibration or one cycle. Start in here from this point. When this wave, it keeps moving in that direction. When it keeps moving in that direction, it keeps moving until the moving or the motion of this wave, it comes in this point. This is called one cycle or one vibration. From this origin until here, this distance is called one cycle. One cycle or one vibration. This is called one cycle. That the distance that the wave it start from the origin until here, and this distance, all of them until this point, it's called one cycle. Or I can tell you by another way. This wave, if we have 2 waves combined, this become one cycle. This wave from the up and this wave from the down together will be one cycle, because this wave only is only one cycle, and it's one cycle, but together will be half with half will be one cycle, and that whole distance one cycle, because this small wave from the up half, this small wave from the down half, but together will be one cycle. So of course, when any of the wave, they need to complete this cycle to keep moving, but to keep moving until here. For example, the wave would start here, it keeps moving until it reaches in here. Of course, it needs time, right? It needs time. So this time, it's called period. This time's called periods. Now I can tell you by another meaning. The time that the wave it needs to complete this cycle is called period. The time that the wave it needs to complete this one cycle is called period. I'll look at here. Definition of the period: the time that needs to complete one vibration or one cycle, this is called period. And the unit of period is measured by cycle, of course, because period is time. That's why. Okay. The last one that we have in here, frequency. Frequency, the number of oscillation. Frequency, the number of oscillation or vibration that the wave covered in 1 second. Frequency. Look, now you know, because I told you, you understood what was wavelength and period. The last thing that you have, frequency, and the symbol of the frequency is F, which is equal to 1 over T. Frequency. Frequency, the number of vibration or the number of oscillation or the number of cycle, we can say like that, the number of the vibration per the number of the vibration per unit time is called frequency. For example, and here we have vibration. For example, with time, if you count it, you have 1 vibration, 2 vibration, 3 vibration, 4 vibration, 5, and so on. If you have 5 vibration, this 5 vibration, maybe this 5 vibration, it takes 2 seconds, maybe 2 seconds, and 5 vibration per 2 seconds. This is called frequency. Frequency, the number of oscillation or the number of vibration that covers in 1 second. Or we can say like that, yes. For example, in 1 second, how many vibration we have? For example, 1, 2, 3, 4, 5. This 4 vibration per 1 second. This is called frequency. And this is the rule of frequency, 1 over T. And let me tell you what is the unit of frequency. First, this one is stable constant. Write down the one again. And the unit of time is second. So 1 over second, this is the general rule of frequency. Frequency rule, which is equal to 1 over second. So instead of 1 over second, we can flip the second. So we can flip it. It goes this second to the up. It becomes second minus 1. Or even though we can, instead of 1 over second, write down hertz. So 1 over second and hertz, both of them is the unit of frequency. Be careful. Look. Time is period, frequency, and the frequency is measured 1 over second or hertz. This note, I told you, electromagnetic wave are transverse wave. Which the electromagnetic wave are transverse wave. Why? Because electric and magnetic wave are perpendicular to each other. The direction of electromagnetic perpendicular. So it means the angle between of them 90 degrees. This table important, for example, really important to know the type of electromagnetic wave. We have some type of electromagnetic wave. This is all other type that I highlighted for you by the yellow color. First type of electromagnetic wave, radio wave and microwave and IR, infrared wave, visible light, UV light, X-ray, gamma ray. This is the type of electromagnetic wave, and that one is the application. Yani, for example, this radio wave, why this radio wave, it can be using in which of the range in our life. For example, radio wave, we are using radio wave in radio, in television. Or microwave, it's useful for using what? For example, radar, atomic and molecular, or air, or navigation. Microwave, for example, oven. Or IR, we are using IR in which of the range, or in which of the things in our life. We are using in the physical therapy and so on. Visible light, clear. Visible light, is the light that came up from the source, the sun. So they are giving visible light. UV, same thing. X-ray, X-ray, this is the light, but this X-ray it's used in most of the people, especially the doctors are in hospital. They are using X-ray for treating the patient. We are using X-ray for what? Medical examination of the bone or teeth or organ, treatment of type of cancer. For example, we are using X-ray to detect your whole body. For example, your bone is it broken, or your organ. So this is one of the type of electromagnetic wave, and that the application of X-ray are used in medical examination, bone, and so on. Gamma ray like X-ray, both of them, gamma ray and X-ray, are using in a medical examination, in medical field. Gamma ray treatment of type of cancer, again, same thing. So all of them are type of electromagnetic wave. All of them are type of electromagnetic wave, and this application is the field that we can use this radio wave in which field of our life. For example, we can use a radio wave in AM, FM radio, and X-ray, for example, medical examination, and so on. Just be careful, guys. In here, as I told you, the direction of oscillation magnetic field and electric field we say is perpendicular, 90 degree. This is the direction of magnetic field, and this is the direction of electric field. So the angle between of them, 19 degree. 90 degree. Look at this too. This is the magnetic field direction, and this is the electric field. The angle between of them, 90 degree. Okay. The direction of electromagnetic wave consists electric and magnetic wave and a right angle. Right angle to each other. Right angle, it means the angle 90 degree. We have this wave speed equation. Rule important because now we are solving example. C, it means speed of light, and every time speed of light which is equal to 3 times 10 power 8. I told you and before, every light, let me tell you one thing, wait a minute. All of the type of electromagnetic wave now that I mentioned, all of them, their velocity of all of the type of electromagnetic wave, which is equal to 3 times 10 power 8, because all of them type of electromagnetic wave, and I told you electromagnetic wave velocity motion all of time or every time 3 times 10 power 8 meter per second. This is stable constant, it won't be changed every time the type of electromagnetic wave they are moving with this velocity. So speed of light every time 3 times 10 power 8, and we have in here frequency and times lambda. This lambda I told is wavelength. We have now this relationship between frequency and wavelength are inversely proportional. Let me teach you or tell you one important thing, even though you will get benefit in grade 12 and grade 11. This is the rule. Look, this is the rule. C equal to F times between F and lambda multiply. The relationship between frequency and wavelength, the relationship between of them inversely proportional. Every time, if we have two letters multiplied together, the relation between of them inversely proportional. Every time, inversely proportional. You know what is the meaning of inversely proportional? It means, for example, maybe one of them is going to be increase, but the other decrease. And all of them are changing not directly, inversely. One of them increase, the other decrease. For example, if there is more frequency, it means we have shortest wavelength. But if you have a longest wavelength, it means you have a shortest frequency. And the relationship between them inversely proportional. Now we are going to be solving example. This example is solved and easy. You can do it by yourself. I'm going to solve this all of you now for you, inshallah. Let me start from the first question. Okay. Question 1. A gamma ray are objects in the universe that emit a pulse on the gamma ray. In the universe, some of the objects they are giving us some of the pulse with the gamma ray. The type of the electromagnetic wave that they are giving is it is a gamma ray from this universe, and gamma ray with a high energy. The frequency of the most energy has been measured at this is the frequency. How we know Mr. this frequency? Because the unit is hertz. If the unit is hertz, yani this frequency. So the question said, what is the wavelength of the gamma ray? What is the wavelength of the gamma ray? Immediately I'm going to solve it in here because easy. What was the rule? C equal to F times lambda. So the question said find wavelength. So it means we have to go to find this wavelength. How we can find this wavelength? Divide both sides by F frequency because we need to find wavelength, and this frequency, both of them going to be cancelled, and only this wavelength is left. Wavelength, which is equal to C over F. Equal C. This is the speed of light, and the speed of light every time we said 3 times 10 power 8. Right? What about the frequency? The question they gave the frequency's value, which is equal to 3 times 10 power 21. 3 times 10 power 21. So we can divide it. This is easy actually. Even doesn't need calculator. So the 3 going to be cancelled. Only 1 is left because 3 divided by 3 equal to 1. 1 times. You know this is fraction, and fraction it means division, divide. So in divide we have to minus the power. So 10 power 8 minus 10 power 20. And first of all write down the 10 and minus both of them. The power of the up minus the power of the down. So 8 minus 21, how much is left? 8 minus 21 will be negative 13. Negative 13 what? This is wavelength 1 times negative 13 meter. But sorry, I forgot to tell you the unit of wavelength it measured by meter, sometimes micro. It depends because wavelength is distance. Okay. Okay. So the first example's answer 1 times 10 power negative 13. Question 2. Question 2. Question 2. The question 2 said, what is the wavelength range? What is the wavelength range for FM radio band? We have to find wavelength, but then you be careful because in here we have two frequency. This is frequency rule. Most of the students they will get confusing. Mister, in here we have minus, so you have to minus both of them. No, why you are minusing? This means we have two wavelength. This means we have only two frequency. 88 megahertz. We have hertz. Yeah, this is the frequency. 88 megahertz and 108 megahertz. In here, be careful. We have by megahertz. So now to solve this question, look. In here we have two wavelength. Question 2. So because we have two wavelength, we have to find. Sorry, because we have two frequency. You have to find two wavelength for each one of them. And first of all, we are going to find the first wavelength for the first frequency and the second wavelength for the second frequency. Look. The first frequency that we have. This is question 2. 88 megahertz and 108 megahertz. 88 megahertz and 108 megahertz, because we have two frequency number one, frequency number two. We have to find the two wavelengths for each one of them. For example, for the first frequency, we are going to find the first wavelength, and for the second frequency, we are going to find the second wavelength. So you have to use two rules in the same time. The first one, C, which equal to F times lambda. C every time is 3 times 10 power 8, so it won't be changed. Only we have changing between frequency and lambda. So because first of all we are going to use this one, so in here we can name it by frequency number 1 and the wavelength number 1. So the question said find what? Find the wavelength. How we can find wavelength? Again, divide both of them by frequency number 1, frequency number 1. These two frequencies going to be cancelled. So the first wavelength, which is equal to C over F1. C 3 times 10 power 8, the speed of light every time. And the frequency number 1 in here that you have 88 megahertz. Students, look. In this section, in the every time, the unit of frequency, it must be hertz every time, but in here we have megahertz. So in here we have to change megahertz from megahertz to hertz. I mean, it's not hard, don't get confused and scared, because 88 megahertz converted to hertz. The rule, if you remember in chapter 1, the table that you have studied, what was the rule for converting mega? Mega, we said 1 mega equal to 10 power 6, right? 1 mega. So 88 megahertz, to convert to hertz, multiply by 88 times 10 power 6 hertz. To convert megahertz to hertz, multiply by 10 power 6. Because for converting we have to use, actually we have to convert the rule. Okay. So now this is the frequency value. Put this frequency value in here. 88 times 10 power 6. Yalla, this is only dividing. 3 divided by 88. 3 divided by 88. The answer is 0.034. 0.034. And we said because in divide you have to minus the power, write down times 10, 8 minus 6, 2 is left. So this is we have found the wavelength. So in here we are going to write down meter. This is the value of the first wavelength. Good. The second one, this is the second wavelength. The value 108 megahertz. Again, you have to find this wavelength to second wavelength, which is equal to C over frequency 2. The value of C, 3 times 10 power 8 over frequency number 2. Frequency number 2 is 108 megahertz. Again, you have to convert to hertz, multiplying by 10 power 6. So it will be 108 times 10 power 6 equal 10 power 8 minus 10 power 6, only 10 power 2 is left. Multiply 3 divided by 108. 3 divided by 108. The answer is 0.0277. So the answer is 0.0277 times 10 power 2 meter. So this is the second wavelength. This is about question 2. Question 3. Question 3, same thing. Question 3. Look, students, question 3. Question 3, actually same thing. If you can read in here with me. A shortwave radio is broadcast between 3.50 to 29.7 megahertz. Again, what range of wavelength? Same thing. convert both of them to hertz, then use two use two you have to use two rules for each one of them, since in here we have two frequencies, so you have to find two wavelengths. Look at question 4. How much easy question 4. Question 4, the question said, question 4, what is the frequency of electromagnetic wave if it has a wavelength of 1 kilogram? So this is the wavelength. So the question said, what is the frequency? Find the frequency. Yeah, find frequency. Look, this is the wavelength, 1 kilometer, and find frequency. This wavelength, as I told you, every time it must be meter. So you have to convert 1 kilometer to meter. This is easy. What was the rule for converting kilo? Kilo, we said every time 1 kilometer equal to 10 power 3 meter. So to make it meter, we have to multiply by 10 power 3. 1 times 10 power 3 meter. So this is the wavelength. This is the wavelength by meter. So immediately you can find frequency. Yeah, C, which is equal to F times lambda. Find frequency, which is equal to lambda, C over lambda. The speed of light every time, you said 3 times 10 power 8, and instead of the wavelength we are going to write down 1 times 10 power 3. 1 times 10 power 3. Good. So 3 divided by 1, still 3 times, write down the 10, 8 minus 3, 5. So this is the frequency we have found in here, and the unit of frequency, it was hertz. So the answer, 3 times 10 power 5 hertz. And so on. All of them are, guys, students, all of them so easy, still same rule. But one thing I want to solve it for you, because there's a important question 5 and 6 is only the important thing. You should be careful to convert the unit, only this one. In here we have this wavelength by nanometer now, by nanometer. We have to find the frequency if the wavelength we have in here by nanometer. So be careful, but it's still easy. Take a look. Question 5. The wavelength in here that you have 560 nanometer, and to find the frequency, if the wavelength you have by 560 nanometer, how you find the frequency? Find frequency. You'll apply the same rule, C, which is equal to F times lambda. Find the frequency, which is equal to C over lambda. And instead of the value of the speed of light, which is equal to 3 times 10 power 8, and instead of the wavelength in here that you have 560 nanometer. So to convert nanometer to meter, we have to multiply by 10 power negative 9. Nano 9. So will be 560 times 10 power negative 9. Frequency, 3 divided by this number, 3 divided by 560, the answer is 0.00535 times. And here, students, be careful in here, because in here we have negative 9. So first of all, write down the 10, and write down this 8, and we said in divide you have to minus the power. Write down the 8 and add a negative sign, then open the bracket, because in here you have another negative 9. So still you have to minus it, but put this negative 9 inside the bracket. So then negative with negative will be positive, will be 8 plus 9. Okay, 8 plus 9, so it will be 17. So the last answer is 0.00535 times 10 power 17 hertz. Good. Question 6. Question 6 actually you can do it by yourself. Again, the same thing you have in here. The wavelength that you have by 125 nanometer. Convert this nanometer to meter by multiplying 10 power negative 9, then find frequency again. Same technique and same thing like the question 5. You can do it, same rule. Okay. We have now another topic which is called, we have some definition first. Some definition here we have luminance, flux, and illuminance. What is the meaning of all of them? Luminance flux. Luminance flux, you can read the definition. The definition said the rate which light emits from the source measured by luminance. For example, when you have any object or the sun, some of the red light came out from the source. This is called luminant flux. That's all. Flux, it means ratio, some rate of the light. For example, this pen is the sun or any object. A lot of light radiate outward. Some of the light came out from this pen. So for example, in this direction came out, in this direction came out. So the rate of all of this light came out, or the value, the rate, the flux is, or this light came out from this source, is called luminance flux. The rate which light emitted or came out from the source is called luminance flux, and the unit, be careful, the unit of the luminance flux measured by lumens. Be careful this one. So luminance flux, the rate which light emit from the source and measured by lumens. We have another thing, another definition, which is called illuminance. Illuminance. So luminance flux is only the rate when the light came out, but illuminance, the luminance flux divided by the area. Let me do it in here for you. Look, for example, this is the sun. There is a lot of light came out in here from the sun, and in here we have this area, any of the space area, for example. Just understand what I'm going to say now. If we take only this rate of the light came out from the source, if we take this light came out from the source, only this is called luminance flux. But when this light it passed through this area, when the light came out from the source, it's radiated outward and it keeps moving to pass this area, the totally called illuminance. Illuminance. So yani when the light are passing through the area become illuminance, but only when the light came out from the source called luminance flux. And that's the difference between all of them, and that's all. So now you understood the difference between them. Luminance flux when the rate of the light came out, but illuminance when the rate of the light came out and it passed to the area. This become illuminance. Now we have a principle which is called Huygens principle. Huygens principle states that all of the point of the wave front of the plane wave can be treated as a point source. Each of these point sources produce a circular spherical secondary wave. You can understand here actually. Let me tell you here where's the Huygens principle. Students, let me ask you a nice question. I mean here, if you notice that only we have one source. This is the source and this is the sun. The light came out from this sun and it passed through all these three areas. And we have three areas. Area number 1 and 2 and 3. I have a strange question. Even though we have only we have one source, but we have three areas. How this light can pass through all of them? one source with three area. How? This is called Huygens principle. The Huygens principle said when any of the light it passed, for example, this is the first light, passed through this first area, right? This is the area number one. This area number one, for example, it consists a lot of points. Each of the points become another source from the second area, this one. And when this light it passed the first area, right? Each of the point they are receiving this light. So this light again become another source. That's why this area, we can say like that. This area become a source from this first area become another source for the second area. That's why this area are radiated a lot of light. Look, يعني this is the sun and it radiated some of light came out from the sun. It passed through the first area. This area, if you notice that light came out from this area. Why? Because this area become another source. The same thing is right for the second area. Same thing is right. When this light it passed to the second area. This second area, look, if you notice that behind this area, light came out. Why? Because this area become another source from the last one. In general, when light passing through any object, this object become another source for the next area it came. When the light it hits this area behind, look, light came out. Light. How this light came out? Do we have any source here? This area is the source. This area become a source. Light came out behind it, and this light passed through this area. Again, same things it's right and happening. Light came out from this area. All of the light came out from each of the area. The reason is this sun, because this sun it passed to the first area, the second area, the last area. But when it passed the first area, this area become a source from the second area. This second area again become the source for the last area. So this is called Huygens principle. The Huygens principle said when any of the light passing through any of the area, for example this area become new source. When we know what's the meaning of new source, it means light come out. This is source, light come out. This again source, light come out. So this is called Huygens principle. Huygens principle. Look, I state that all of the point of the wavefront of the plane wave can be treated as a point source. All of the point in here that we have point. All of them can be mentioned like that. Can be said. We can say like that. All of the point become a point source for what? For the upcoming area that it has skin behind it. I mean this one. Okay. Each of these point source produce what? Produce a spherical secondary wave. So each of these point source produce a circular. If you notice that the direction, the shape, it's circular. Look. We have one thing important. One thing is important. I'm going to tell you. Look, we have a relationship between illuminance and square of the distance of the source. Look, we said what is illuminance. Illuminance, when the light are passing through the area, this is called illuminance. Yeah, for example, in here, these light are passing through this area, so this is called illuminance. But if you notice that the light in here is colored totally different with comparing with the light in here, the last one. There is a big difference between both of them. In here we have a number. Why this? In here we have 1 meter. What's the meaning of this meter? It means the distance between this area with the source only 1 meter, and this is 2 meter. The distance between this area with the source 2 meter, and that one, the distance between this area with the original source 3 meter. So when the distance of the area going to be increased comparing with the source, a few light can pass through the area. If we notice that in here the distance only 1 meter comparing with the other than those one. In here the distance 1 meter comparing with these two areas. In here the distance only 1 meter. So if you notice that a lot of light are passing in here, look the color. But the second one, if we're going to increase the distance, now we make the distance 2 meter. If you see that, yes, we have light, but if you to compare the color, this color is totally different than that one. It means light falling on this area, right? But comparing with the first area, we have less and a bit light falling or passing through the second area. If still we keep increasing the distance to make it 3 meter, we see that the color light totally different comparing with the first one. Why? Because we increase the distance 3 meter and a few less light are falling to the last area. Look at this two color totally different. Their color totally different. This is so brightness, but that one not. That's doesn't. So while we are increasing the distance, when you are increasing the distance, a few light can passing through the area. So the relationship between, that's why the relationship between illuminance, it means the light are passing through it, decrease. Yeah, the luminance decrease. Look, the luminance in here now. Which one of them? Which of the area that their luminance is less or decreasing? Of course, the last one. In here we have less luminance, yani less light falling on this area, because we have a lot of distance. We increase the distance between of them. So illuminance decrease. Look, illuminance decrease as the square of the distance from the source. It means when we are increasing the distance, we see that the illuminance decreases. But when we are if we are increasing the distance, the luminance decreases. But if we are decreasing the distance, if we are reducing the distance, we see that a lot of light falling the area. If we are decreasing the distance, illuminance increasing. But if we are increasing the distance, illuminance decreasing. I hope to understand. Actually, it's important. Okay, so now we have some notes. What does intensity of light depends on? If you notice that, I know what's the meaning of intensity. It means, for example, on this area, a lot of light are passing through this small area, and here it means we have a lot of intensity. The amount of energy emitted from the source. It depends on this value of energy that came up from the source. Because if we have and it is written directly proportional, because if we have less energy, it means at the end less intensity of light that can pass in through the area. So the relationship between amount of energy and intensity directly proportional. The square distance from the light source inversely proportional. Of course, now we said, because if we are increasing in here the distance, if to increase the distance from 1 till 3, yani we increase the distance, we see that the illuminance, we see that the illuminance decreases. Look at the light, different, yani less light fall in the area. But if we have less distance, we have a lot of illuminance. So the relationship between inversely proportional. These two not important, students, and it was important. We have this important question again. Why the illuminance of light decreased as we got farther from the light source? Why the illuminance? The question said if we are going far away, for example, we are in here, then we can increase the distance. The illuminance is going to be decreased. Again, we are going to increase the distance more. We see that the light in here, illuminance is going to be decreased. Why? Because we said, because illuminance inversely proportional with the square distance of the source. And that's it. Section 1 actually done, finished. So now we're going to solve example. Question 1 that we have. Identify which portion of electromagnetic spectrum are using in each of the device listed. Identify which portion of electromagnetic wave. Okay, for example, microwave oven. In microwave oven, we said the type of which type of electromagnetic wave are using? Microwave. Television, AM radio, or radio wave. Television. The first one in here, microwave. Microwave. And a television radio wave. Part B, television radio wave. The last one, single lens reflex camera. This is visible light, that a type of electromagnetic are using in single lens visible light. Question two, you can't do it by yourself. We have this frequency. What's the wavelength? We solve it. Question 3. A Galileo performed an experiment to measure the speed of light by timing how long it took light to travel from the lamp, and he was holding an distance about 1 kilometer away. Why was Galileo unable to? Okay. Question 3. Or not question 3. Question 4. Question 4 important. Look at question 4 example. How bright would the sun appear to an observer at Earth if the sun were important, if the sun were 4 times farther from the Earth? 4 times. If the sun 4 times farther from the Earth, 4 times far from the Earth, actually. Express your answer as a fraction of the sun brightness. Okay, 4 times. And we said the relationship between of them, inversely proportional. We can use this rule. I forgot actually to tell you. We have rule to find this. The question said, how bright will the sun appear to an observer on Earth if the sun, for example, this is the sun. How bright will the sun appear to an observer on the Earth if the sun were 4 times farther from the Earth? For example, this is the Earth, and the distance between of them 4 times. So how you can find how bright will sun appear? We have the rule to use this relationship. Illuminance which is equal to 1 over r square. R, it means the distance between the source and the area, the distance. So how we can find the brightness or illuminance? Illuminance, we can write illuminance equal to 1. In here it is written 4 times, instead of the radius, because the distance between of them 4, radius r, distance r, so we can write down 4 will be square. So the answer will be 1. 4 power 2 will be 16. So the answer, illuminance, when the distance between sun and Earth 4 times, the illuminance changed by 1 over 16. So 1 over 16 of the sun brightness on the Earth's surface. 1 over 16. Students, we have finished to explain section 1. Inshallah, for the upcoming video, we'll keep moving, and for the next video, inshallah, we will study section 2, chapter 5. Thanks for watching.